Okay, let's get started. So, hello everyone. Welcome to the P4 GSoC kickoff meeting. And I am Billy, and I'm helping organizing this and with the whole team, including many others. And here's the agenda for today's meeting. We will give an overview of the P4 GSoC program, and then we are lucky to have Andy to give us an introduction to the P4 open source community. This is mainly for our new contributors. And in the last part, you'll get to know all our contributors and the projects they will work on. So now first, this is an overview for this whole program. And so some of you might heard Google Summer of Code for the first time. So essentially, this is a global online program focused on bringing new contributors into open source software development. And in this case, this open source software is P4. And this year, the P4 organization is participating in GSoC for the first time. And if you want to find more relevant web pages, you can search P4 GSoC on Google, and the first few results should be us. The current status is that we have 4 contributors and their proposals accepted into the program. And the official coding period will start next week, and it will be roughly 12 weeks. And if by the end of this meeting you get interested in any of these projects, and there are several ways you can get involved. First, you can find, so these are essentially normal open source development, so you shall expect to see relevant issues and pull requests on our GitHub repos, and you are welcome to leave your comments there and join any discussions. And second, on the P4 Slack workspace, we have created a GSoC 24 channel. You are also welcome to join that channel and have any discussions. So that's all for the overview. And now let's welcome Andy for the P4 open source community introduction.
So welcome, everybody. My name is Andy Fingerhut. I am currently the chair of the P4 technical steering team, and been involved with P4 for pretty actively since about 2017. Hobby and work, both. So I just wanted to give you a quick overview of some of the projects. First, I quickly want to say the projects that I'm describing here, this P4 Lang organization on GitHub, is not the only open source stuff related to P4 that's been published. Just as one example off the top of my head, I don't have a link here, sorry, but a guy named Ryan Goodfellow who works at Oxide Computer has published a P4 to Rust compiler written in Rust. So that's not in the P4 Lang organization on GitHub, simply because he's been developing it on his own and chose to do it under his own organization instead. So what I'm going to describe to you today briefly is just the P4 Lang organization on GitHub and the projects, some of the projects that are there, and then how we do open source contributions there. So, oh, and it looks like Fabian has put in a link to that other P4 compiler in the chat. So if you go to the P4 Lang organization on GitHub, you can see a list of all the 43 repositories. I don't have a list of all 43 of them here. I've chosen to list selected ones as the most active or most recently active. By far, I think P4C, the P4 compiler, is the most active one, partly because of Fabian Ruffy's recent efforts to get a lot of issues through and code cleaned up and features added. Thanks, Fabian, for that. The behavioral model is the BMV2 software switch. It lets you, it's sort of the flagship used for testing the P4 compiler with actual packets going through a software switch from the compiled output of the compiler and making sure that the compiler is outputting correct things and processing packets as desired. There's P4Pi, which is some open source packaging together instructions and tools for installing a lot of these tools on a Raspberry Pi platform. P4 Constraints is developed by some folks at Google, I believe, have spearheaded this. Basically, at runtime, you could give annotations in your source code, P4 source code, which will then turn into software that at runtime enforces checks constraints on what table entries you're allowed to install at runtime. The tutorials repository has been used for several tutorial sessions in the past. Public tutorials at places like SIGCOMM and the P4 workshop. There's several repositories all related to the table-driven interface, which is a different runtime API from the P4 runtime. Two different ones for installing modifying table entries. And then there's several repositories here that are primarily they're not primarily code, they're primarily specification documents like the language specification, the portable NIC architecture specification, and the P4 runtime API specification. They have a little bit of code, but they're mostly specification. Let's go. Yep, one more. So the common workflow for contributing code in these repositories is similar to many GitHub repositories. It's I don't know if it's the standard GitHub workflow, but it's a pretty common one I've seen in other open source projects as well, which is anybody that wants to can create, even if you have no special permissions, just read permission on these public repositories. You can fork a repository, create a branch, clone it, create a branch in it, make some changes, commit them locally, and then create a pull request. There's instructions on, if you search for GitHub pull request workflow, on ways to do this, as the detailed steps. After that, so that at that point, your proposed changes become obvious to, visible to the owners of the maintainers of the repository, and they'll often, one or more of them will, if they're interested and knowledgeable in that area, might make comments, suggestions for changes, questions about why your approach, and or if they think it's perfect, they'll approve it. But that often requires several rounds of review and changes before that happens. And all of the projects in P4 Lang that I'm aware of, it's very rare for them to have long-lived branches, and so they all tend to work on main or master branch where all the development is done and all the pull requests are merged in. Occasionally, I think there's P4 runtime API spec currently has a long-lived branch that is expected to be merged into main, but it could be a year or so before that happens. But in general, most of the other repositories don't have that. Maybe all of the repositories are under, the contents are under the Apache 2 license. So if you're concerned about that or want to know more about it, there's an Apache 2 license description, and I think there's a website comparing what code compatibility matrix for different open source licenses you can look at if you're curious. One thing I would remind folks is all reviewers are volunteers. Many of them have full-time jobs. Most of them have full-time jobs. Most of them don't have full-time jobs being paid to review P4 contributions. Often they do it as a hobby or a very part-time thing. So be patient, and if you submit a pull request, if you feel you've been patient and haven't heard anything for a while, you can feel free to add another comment saying, hey, does anybody have time to look at this? But just realize that there's not a long list of people sitting there waiting for your code to come in and review it the instant it comes in. It depends on interest and time. Any questions or comments? All right, thanks.
Okay, thank you, Andy. Now let's move on to our contributors and projects. And the first is Adash.
Greetings everyone, my name is Adarsh. I'll be sharing my screen a bit. Wait. So I'll be working on this project, enhancing P4 compilers project documentation. And I'm from India. I'm currently pursuing my master's in computer application. So the challenge that we are facing right now with documentation is that it is not usable on mobile devices, and it has a lot of issues with navigation and stuff. It is not easy to find things that we are looking for, and the website is actually not deployed on any platform. So if you want to actually access the documentation, there is a hindrance of building the documentation locally. And this can significantly, this can be a problem for new contributors, as they are already not aware of the tools that are used for building the documentation. They have to set it up completely. And that definitely is a barrier that prevents new contributors from onboarding P4. And the resources of documentations are also scattered in various websites and presentation. So these are the challenges that we have currently in this project. So we have two approaches for solving this. The first approach that we discussed was using Doxygen along with Spinix. So let me introduce you to these tools. Doxygen is a tool that is used for generating documentation from the README files along with the comments that are placed in code. And it does a fairly good job at it. But the output that Doxygen gives is not mobile responsive, as we saw in the previous slide. And it is also not easy to navigate. So this is where Spinix comes into the picture. Spinix is a tool for making our documentation visually appealing and easier to navigate. And it also supports new features, and it is easy to swap themes and customize our website with time if you want to. And the approach too that we have for building the documentation is using Doxygen along with Doxygen Awesome CSS. It is an initiative, open source initiative, where they have built a CSS for Doxygen generated output, making it more accessible along with features. So it has better mobile usability. It has a consistent theme all throughout the documentation. And also it has many features that we can add with time as we need. Like there is a table of content, page navigation. These features are not available in Doxygen by default, but Awesome CSS allows us to use them in our documentation. It also allows for paragraph linking. Like we can, this way, if someone is asking a doubt, then we can directly share the link of the documentation of the part that we want them to know or something that we want to share. And dark mode, that's a basic feature. So why did we choose we are actually going with the second approach instead of integrating Spinix, since there are less number of tools. So there will be easiness in maintaining the code base, as we know that all the contributors are mostly hobby contributors, or who contribute, they have some other works also going on. So if we make it too much complex just for the sake of presentation, then it won't make much sense. That's why we are going with Doxygen along with Doxygen Awesome CSS, which provides us with all the features. We are not compromising on the feature part. It's just that we won't be able to swap themes more often, which I think is not a very important thing to consider while building documentation. We can have a consistent documentation. So also we are deploying this website on GitHub pages, which allows us to keep our deployment free. And also it is easier for everyone to work, as we are all familiar with GitHub and working of GitHub pages without the need for learning something new and configuring it. We have also some basic improvement, like the diagrams or the graphs that are generated using Graphic Viz. It's a tool inside Doxygen that is used for generating graphs and relationship between class and functions. So this is like the home page that I have currently built. This is a like a progress that we have made till now. You can also check this link out. This is where I have deployed this web page, and you can definitely share your thoughts and feedbacks on this website, and we will try to include them. Currently, this is in development phase, so you might find few graphs are not there. So do let me know if there are any issues. I'll fix them. Uh, the code is also hosted on this same GitHub repository. You can put your comments there, or you can raise the issue if you see a problem. So this is what we are able to achieve till now. We have a modern theme which is responsive on mobile, as you can see over here. I have attached a screenshot of the mobile device. It has less maintenance overhead, as we are using just two tools. Doxygen was already configured, but we need to like update it to the latest version, and few more additional configuration would be needed, along with Awesome CSS, which is like basic CSS that we use with HTML. So it will be easy to customize. We will be having high availability of documentation, as there is no need to build the documentation for new contributors, they can directly go to the website and access it. It is live right now also. And since I'm using GitHub Action on my GitHub repository, so it will be up to date with every commit that we make. So it will be always up to date and also available to all the new contributors. So if anyone has any comments or any suggestions, so I'm open for that, because documentation is something that I might think that this is looking nice, but for you, there might be features that you want. So please let me know. You can send those as issues in my GitHub repository, and I'll include them before actually merging into the actual P4 repository. And as a part of future step in the same project, we will also be developing the tutorials website. The repository that we have P4 tutorials, we will be developing a site for that as well and configuring a GitHub workflow for that. So thank you. That's all from my side. If you have any suggestions, do let me know.
Thank you, Adash. So any questions from the audience before we move on to the next project?
So sorry, I joined a little bit late, but is the ultimate goal for this to have these hosted as like docs, docs.p4.com and like tutorials.p4.org and things like that, and have them be like real first-class things?
I couldn't hear you. Can you please repeat?
Oh, I'm sorry. Are you guys able to hear me now? No?
Better.
A bit better.
I'll just post my question in chat. Sorry.
Okay.
I think I was able to understand most of it. So the question was whether the ultimate goal is to have this as first-class docs on the P4org website, right? For the various repositories. Yes, that is the end goal, and we're starting out with the compiler, and then we see how that works, and from there we just if the theme works nicely and if the integration works nicely, then we can just expand it to all the other repositories.
Actually, I have configured it on one of my repositories, so you can check it out. The link that I have given in the presentation, I'll share the repository with you, and feel free to post your suggestion in issue tab or wherever you feel like.
One question. Where is so currently the web page includes only the compiler, the documentation of the compiler, and I assume that other repositories could be, for example, BMV2. And I was wondering whether this will be later on merged into separate repository only for documentation, or it will be part of the compiler, or
It will be the part of original repository, as you can use awesome CSS as a folder. I'll add that folder to the repository. There is already a docsystem configuration file in P4 compiler repository, and I have set up a GitHub workflow action that generates the documentation and stores it in a different branch, GH pages, from where it is deployed to GitHub pages. So it will be hosted on the same repository. You won't be having like a different repository for that. Currently,
I think ultimately,
different repository for testing purpose and for feedback purpose only, because I don't want to pollute the actual repository with feedbacks and stuff.
yeah, I think ultimately we can make a full documentation repository, but for now I think it's good enough to start with the compiler. We'll see how far we go.
yeah. What is the plan for the summer? Do you plan to cover essentially several repositories to some extent, like have some getting started documentation sort of, or you focus deeply on one repository, for example, compiler?
Initially, I'll be focusing on compiler because that is the main project, and I have like almost configured it. I'm just waiting for the feedback so that I can finalize it, and after that I'll like compile all the content that is there, because it is not updated. We have to update it. The directory structures are obsolete, like they haven't been updated 5 to 6 years. And once I'm done with that, then I can move to other repositories, like I mentioned tutorials one. So for tutorials, I might use a different configuration as the one I shared using Spinex, because it provides for better visual appeal, and tutorials are usually followed by someone who is just starting. So it would be better for them to have a better view of things. But it is totally unnecessary in case of compiler documentation, because we aren't having much visual components there, and graphs are better used with Oxygen.
Thank you.
Yeah, thanks, Adash. So maybe we can move on to the next contributor and we can have more discussion towards the end. So now Nitish.
Yeah, let me just share my screen. So hello everyone. My name is Nitish Kumar. I'm a fourth year undergrad studying at Indian Institute of Technology, Kharagpur. So I'm an avid open source enthusiast. I've been contributing to open source from my first year onwards. Some of my notable contributions were in Rust core utils, Nixos, Packs, etc. My primary interest is in compilers, networking, and distributed system. Currently, I'm working as a Linux Foundation mentee at RIS 5. This will end this month, so at around 30th. So this is my GitHub link. My hobbies are badminton and tabla. So tabla is a classical Indian instrument. So as I told, I will be working on the formatter project. So currently we have a pretty printer to P4. What it does is it traverses the IR tree and just simply pretty prints source code, right? Uh, but these have many problems. To have a fully fledged formatter, we have a couple of roadblocks which we need to get over to reach there. The first one is the comment information. Comment information are currently dropped from the AST. And as we know, to have a good formatter, comment information is very necessary. Second is to P4, as I've told, it's very simple. It just data prints a tree. It's very inflexible. It has very limited formatting capabilities and almost nil customization options. It just prints the thing. We also don't have any preprocessor oriented checks. So currently, my plan is to have this in a three-phase solution approach. In the first phase, I'll be dealing with addressing the comment preservation and association, like associating the comment with the actual ST nodes. In the second phase, I'll be developing the actual first iteration of the formatter, and then later I'll be providing configuration option and handling preprocessor directive, those kind of things. Yeah, next slide. So I have a couple of solution approaches in mind. The first one is uh, what is currently employed by GoAST. So GoAST currently maintains a separate list of comment along with the source information. We already have this information currently stored in a struct. So, and what GoAST does is it just associates the comment with a relevant node while pretty printing. It's pretty basic stuff, but it comes with a couple of downside. As you might have seen when you go to the GoST issues page, there are a lot of problem with this approach. So one of the major problem is incorrect association of node with a comment. Since we only have the source information to work with, it's very hard to associate the correct comment with the correct node. Right? We also have many refactoring challenges. If you refactor the code, the association gets messed up. So the comment get associated with other code construct instead of what it should have been associated with. It also puts heavy load on the printer. So this is the solution approach two, which I am planning on going about. So this introduces a separate field for the comment type for the each AST node, and the process of sort of attaching the node is uh, if if let's say we have a code construct and a comment is just following it either on the sides or on the top of it, we just attach it to the nearest node, right? The problem comes with the free floating comments. Those are the comments which are not very obvious, like which code construct it should be associated with, right? So for this we are planning on using heuristic based association, so things like proximity based or semantic based. uh, downside of this is not flexible enough to handle all the edge cases. Like we can't really handle all the edge cases, but we'll try to get there. So this we'll start with the approach 2. So this is the third approach which builds upon the previous two approaches. It's just an improvement over those two approaches, and it provides more granularity to it. So let's say we have a function, a variable declaration. So in the previous solution 1 and solution 2, what we did, but we associated the comment with a particular node, a parent node. But if you have a comment like this, in which the comments are placed in between the variable declaration, so I'm planning on having, instead of attaching the comment with a parent node, we can have several code points, and then we'll have more flexibility to attach the things properly in their proper places. It's a bit difficult to implement, but we'll get there. So the plan is to start with the second approach, and if the time permits, we'll include the third one as well. So though the first phase dealt with the comment part of the thing, in the second and third phase, this is the phase where actual development of the formatter will take place. So first approach will be very opinionated, just like what Go does currently. So it has a very strict set of formatting rules, and we'll trying to have that only, and gradually we'll make it very flexible and provide users with configuration options like indentation, line wrapping, sort of like that. These are the deliverable. We will have at the end of the project, we'll have a working P4FMT binary. We'll have comprehensive documentation, some sample demonstration, maybe in the form of video or GIF, and we'll have a comprehensive suite handling all the edge cases. Future work can be to handle the pre-processing directive. Currently, we have Clang format, which has some work done through Indian PP directive, wherein it provide couple of options to format things. We're planning on leveraging that to in our work, because if we think of building a thing which handle this kind of thing from scratch, it will take a long time. So yeah, I'm planning on leveraging that into our project, and more feature can be providing more configuration option to the formatter. That about sums it up, I guess. I'll be happy to take any questions.
Yeah, any question from the audience?
I was wondering if there is, if this project could be extended in the future, for example, with support for linting, because formatting and linting is kind of similar. Something similar to PyLint or.
Yeah, maybe if time permits, like the last step was to handle the pre-processing thing. If time permits, we can definitely go ahead and deal with the linking part too.
Yes, but sometimes it's also useful to describe something like future work. It's useful, for example, next year, maybe there will be other students interested in the project.
Yeah, I should have mentioned this in the slide, but yeah, anyway, sorry for that.
Yeah, I think this is exciting stuff. If you get a formatter, because we're missing a formatter deeply.
Yeah.
Um,
It will help the community a lot, I guess, especially the end users.
so with documentation, you mean instructions on how to use the formatter and
Yeah,
okay,
maybe some sample example and how that would look like.
I see. In terms of configuration options, we stay basic for now, right? We just don't have many.
Yeah,
That's fine.
currently we'll be providing some, and if time permits, we can gradually extend those options.
Yeah.
Like,
I guess I have another question on testing. The testing part will be assuming we could format all the, so we have a lot of P4 programs, right? So I could imagine that to make sure that the formatter works, we can run it on all of these test programs and then see what happens. And see whether we are gonna break them.
there Yeah, there are already a host of P4 source program to work on, so I don't think we would do more. If we
Yeah.
load more, we can just we have plenty of source program to work with. Yeah.
Is that limited to P416 or does it also support P414?
I guess for now it will support P4 16. That's what I have in mind.
Yeah, I mean, it might be possible to, since we're using the compiler, which has inherent P414 support, it is possible to support, but I'm not sure if you want to make it a priority. 'Cause,
Yeah,
some
I
priority.
thought of this. I thought of the project from the perspective of P4 16.
Yeah.
We'll see if it is easy enough. We can just do it.
Yeah, thanks, Nitish. Maybe it's time to move on to the next project. Rupesh.
Yeah, thank you.
So, my name is Rupesh Chilka, and I'm currently pursuing integrated masters in computer science in University of Hyderabad. So, my main areas are like machine learning and cloud computing and networking. And I'm currently in software intern at Marvel Technology, like it's in India. And so, about my project, like it is to like BMV to PNS support, like it is to integrate the PNA architecture to integrate PNS as architecture into the PM network. Like as we know, like the NICs and switches, like they're both different entities. Like NICs have some similar features to the switches, but they also have some differences comparing to the switches. No? It has like a host memory interface, and it also has like different features, different use cases than switch, like the RDMA, like IPsec encrypt and TCP connection tracking, and TCP segmentation upload, and etc. etc. Like there are few use cases that we don't see in switches, like or we rarely see in switches. And so to support NIC, the P4 community has introduced a separate architecture, like to support switch with the P4 community has PSA architecture, and for NIC, the P4 community introduced PNA architecture. So currently we don't have any implementation for the PNA in any backend or any target. Like if we take any backend like BMV2, DPDK or eBPF, UBPF, we don't have any support for the PNA, and we need that support, the PNA support in the software, like and to get started for the NIC for the P4 use case on the NIC side. So the project itself is like to add the support, that support PNA support into the BMV2. And currently the BMV2 only has support for the V1 model and PSA architecture. So my approach is to like to introduce that PN support into the BMV2. Like, so one thing is like I have to create a new backend in the BMV2 repo, and like to add like all the programmable blocks and metadata, and to make it compatible with the already present BMV2 repo. And then after creating this new backend in the BMV2, I also have to update the P4 compiler so that the PNA programs, the P4 compiler should compile the P4 PNA programs, and that PNA program should run on BMV2 backend. So I have two repos to update. Like the one is P4 compiler, and another one is BMV2. In the BMV2, the another extension is like in the BMV2, I also have to implement various extensions for various use cases. Like in the previous like slide, I said like IPsec encryption, decryption, connection, TCP connection typing. So for these use cases, like I have to create the extents for these use cases. So while updating this BMV2, it's not like for now there will be phases while updating the BMV2. So in the first phase, I will only update BMV2 for so that the only PN there will be only forwarding. There will be only PN forwarding of packet from one interface to another interface that follows the PNA. And next in the next interface, next phase, I will add like dropping features, and next phase like recirculation, multicasting, cloning features, and in next phase I will add extends. Like in the different phases, I will add new features in the BMV and P4C, and the deliverables will be the same, like updated BMV2 and updated P4C, and we should have the binaries for the PNS, like for the PN architecture, and as for the future work, like the PNA spec is not completely ready yet. Like there were the PNA spec is currently divided into two parts, like packet processing part and message processing part. Most of the packet processing part spec is defined, and processing part spec is yet to be defined. Like the PNA spec is not yet completed. So as this spec gets updated, like P4 and PNA spec get updated, we have to update the BMV2 and P4C repos accordingly. That's from my side.
Yeah. Thanks, Rupesh. Any question from the audience?
Any
So this is a big project, in the sense of you need to work on two particular repositories, the
yes.
compiler and the behavior model. Have you thought about how to approach your start? Would you just do the behavior model first and then have, for example, a mock output by the compiler that you could use?
First, I thought like I will just introduce PNS skeleton into the BMV2 and P4C. Like if it gets approved by the community, then I will start just a basic packet forwarding, and then the dropping and all those features. And after I get this core subset of PNA into the BMV2, I will start adding extents for each different case, for each use case. That's what I'm thinking.
One thing is there is dependency between the compiler and BMV2. So, for example, the tests in the compiler are using BMV2. For example, if you want to test if the compiler works, you also may need to be able to run the P4 program. So it might be useful to create pull requests in both repositories and then ask the community to.
Yeah, it's that. We have to work on both repos simultaneously so that there won't be any one repo getting forward and other one is not yet started. We have to work simultaneously on both.
Andy, I was wondering if there is a big difference between the existing work on PNA with DPDK and BMV2, or is it quite similar?
Yeah, and like other DPDK backend also has a small support for PNA, but it is like so rigid that we won't any adding new things to that. It is kind of difficult for the DPDK backend.
Are there parts that they can reuse, at least from the backend? I guess you need to you need to produce a JSON, right, for the behavior model versus
for the behavior model we are producing.
Yeah, they both have different intermediate kind of languages output by the compiler that I'd be surprised if there was a lot of reuse possible or much reuse possible at all.
Yeah. I think it might make sense to mock the JSON first and then get behavior model support and then extend the compiler, at least. Because it might be difficult to produce the JSON.
Fabian, actually, I would probably go the other way. So this is how.
Yeah.
I think just getting the BMV2 backend off the ground without any support for the new features that we've added for NIC, like TCP connection tracking or encryption decryption, would be probably, I agree, it's a maybe a slightly longer pull, but that
Mhm.
would give us the compiler at least to target existing P4 programs on Switch, right?
Okay.
That won't use those features, right? So then I think I think extending the model is extending the behavioral model is slightly easier, I think. So once we have this, then we can do the two-step of both the compiler and the model, like Prathustan suggested.
Okay. Makes sense.
And I don't know about you guys, but like having a subset of things working in both the compiler and BMV2 would be nicer than having everything working in BMV2 and nothing in the compiler. So
Yeah,
maybe
that's, I agree. Yes. Yes.
picking an order of features to add that, like hello world, then, you know, slightly more complex than hello world, then, you know, doing a feature on both sides before moving on to a bigger later feature might. It also means that if it goes slower or faster than you think, at least the compiler and the BMV2 are kind of roughly in sync whenever the project for the summer is done.
Yeah, I agree. What I meant was the first would be the basic backend for PNA on BMV2, which does not support any of the NIC features.
Right.
Meaning it compiles against all switch programs. And then, like you said, we do piecemeal both the compiler side and the model side to roll in every new feature that we want to roll in, right? So start with the easiest one first. I would imagine something like an extern, like encryption decryption probably might be easier than something like TCP connection tracking, for instance.
Sure.
Yeah.
Yeah, thanks everyone for the discussion. Now it's probably time for the next contributor.
Yes.
Stanislav.
Yes, thank you, Billy. Let me just share my screen. Perfect.
Yes.
So, hello everyone. My name is Stan, and I'm a master's student at the Technical University of Berlin, studying computer science. I'm currently in my first semester, focusing on distributed systems and networking. And I've just finished my bachelor's at the same university with a thesis focusing on evaluating container migrations on the low Earth orbit edge, basically on a network emulator for the low Earth orbit satellites. And this is closely related to this project as well. I'm also a part-time software engineer at Cresta. I've been working there since 1.5 years, doing full stack development, Go for backend and React for the front. And yeah, you can also check out some of my projects on my GitHub, including this Google Summer of Code project, which will be in a repository on my profile during development. Yeah, and in my free time, I love exploring technologies in general, reading random papers, also do a lot of sports, a lot of running, focusing on improving my time on a 10K right now. And also I love learning languages, currently learning Persian. Yeah, so that's enough about me. So now I want to focus on the project. And firstly, I want to say this project is not directly focusing on the P4 language. It's more of a usage of the P4 language for a real life use case, basically. It's a proof of concept. And for context, for start, Kubernetes supports container checkpoint and restore, which basically means you are able to checkpoint a container on one Kubernetes node, transfer it to another node, and restore it. And this uses the Creo project under the hood, which I won't be going in depth here, but checkpointing includes also the container state, such as memory and the established TCP connections. And basically, when the container migrates to another node, it resumes its operation seamlessly almost. However, the problem is the container IP might change during migrations, and there need to be some networking adjustments made in order to keep TCP connections alive, basically. As far as I know, currently for use cases right now, the connections are simply broken. So this is what I want to address. So the idea is basically to use a P4 programmable data plane to forward traffic to the newly migrated container on the new node. And this is a big project, obviously, and it consists of multiple components. The first one being a P4-based load balancer on the data plane. The second one, a controller to update match action tables on the P4 data plane, on the P4 switch. And the third part is an integration with the Kubernetes network. I will talk about all these components now. So firstly, the P4 load balancer. So this is just a standard load balancer on the data plane, which routes packets to Kubernetes nodes and ensures equal resource utilization. For a start, we want to target the BMV2 switch. Yeah, that's about it. And the controller basically monitors container migrations and then updates match action tables of the load balancer. This is done by utilizing the P4 runtime, basically. And the last part, which is probably the most cumbersome here, is we want to integrate all of this into the Kubernetes ecosystem. And for context, the Kubernetes network is managed by CNI, the container network interface, which manages networking, seamless networking basically between containers and nodes in Kubernetes. And what we want to do is enable the direct communication between our switch and the Kubernetes nodes to allow this forwarding, as mentioned. And yeah, we discussed a bunch of options here, but I guess this could be in the form of a minimal CNI plugin, but we'll see how this project evolves. This is the last part, basically. And of course, in any project of this size, we are going to provide a comprehensive documentation of all the steps taken, all the decisions taken, also how to run examples. Also, we will evaluate these container migrations and the whole process of the system, basically, and also write some tests for some basic functionality. And future work could include to extend this functionality to support SmartNICs or enhance CNI directly with P4. Yeah, I think that's it. If you have any questions, feel free to ask.
So I have a question about the evaluations. Here you mentioned the evaluation of performance. So if using BMV2 software switch, can we accurately evaluate the performance?
Probably not, but we can evaluate the difference between breaking and reestablishing the TCP connections and using the BMV2 switch for this purpose. I mean, obviously the BMV2 switch is not meant for production use, but as I said, this is more of a proof of concept for now.
I see, thanks.
So does this require changes to BMV2 or anything? You may have to modify there, or can you use all the P4 components as is?
Yeah, I think we can use pretty much BMV2 as is. So essentially the problem we're trying to solve is when you migrate a container to a different node and you change the IP address, you have to forward the packets to the new IP address. So essentially what we're trying to do is implement a load balancer on the switch. Then the load balancer keeps track of the IP address of the container. And then the client always sends packets to the load balancer.
And I guess the implementation is useful because you can do it in P4, which is a little bit more flexible if you have a P4 programmable software switch.
Yes, technically, if we implement it on BMV2, then we can try, for example, to implement it on Tofino or like Rio switch.
I see, yeah. Or I guess a SmartNIC.
Yep.
So you basically try to mock a load balancer with this approach and then move on. Okay. So if there, I guess this doesn't require changes to at least the official P4lang repositories, but if there is anything that may require changes, we are of course happy to support there, right?
Yeah, we were considering to contribute at the end of the project to the tutorials repository with an example implementation or something similar.
Yeah, so this would be part of tutorials, right? Or we could make a separate repository for it if it's too big.
Yeah.
Okay, it sounds good from my side.
Right. Thank you. I guess I give the word back to Billy.
Yes, thanks for the discussion. So we still have 5 minutes. So any more comments or questions for any of the projects and for anything from the audience?
Well, I would like to say a quick and big thank you to Billy and Fabian for all the work they've done in getting us to where we are in this Google Summer of Code with P4 projects. So thank you very much for all your hard work. I know it wasn't easy.
Yeah, also thank you, Andy, for today's presentation.
Yeah, thanks. And yeah, Billy did a lot of the organization and messaging. So thanks to him.
Thanks to both of you. Thank you very much, actually.
Yeah, it's
And
Kickoff.
yeah, and also thanks for all our mentors and other, including
And the mentees.
Yeah, and contributors.
So it's kickoff time, exciting. I'm very curious how we're gonna be at the end of the summer and what projects we have. All of these projects are quite useful for us.
Yeah.
So
I guess another question would be, do we I guess the main communication you expect will be Slack and email and GitHub issues probably? Or will there be plenty other in the middle of the summer meetings or anything like that? Or
Our current plan is each project will have their own regular meetings, and all the development will just follow the normal open source development workflow, like mainly through pull requests on GitHub. So anyone can leave their comments there if they are interested.
okay, sure.
yeah. As you might know, there's plans to migrate to Zulip eventually, but for now, everything is in Slack, at least the informal conversations, plus the regular meetings. And then if there's a broader announcement, we probably try to broadcast it via email. And GitHub issues is, yeah, a developer workflow, I think.
Sure, sounds good.
Okay, then it seems we can wrap up today's meeting. Thanks, everyone.
Thank you. Bye-bye.